What does Overcurrent Protection Device or OCPD mean? An Overcurrent Protection Device or OCPD is a piece of equipment used in electrical systems that are at risk of experiencing overcurrent due to overloads, short circuits, or ground faults. For example, a circuit that is improperly routed through an extension cord with a lower voltage tolerance than the rest of the circuit. Most overcurrent protection devices like fuses are found in the primary service panels like fuse box, as well as associated electrical feeders and branch circuits, which are typically connected to their own breaker systems. The particular overcurrent protection devices necessary to protect against overcurrent vary depending on the hazards associated with a given electrical system. First, what is fuse? A fuse is probably the simplest electrical device, but its function is critical in protecting electrical circuits from damage. Fuses are found in every circuit in one form or another in various shapes, sizes, and ratings. As a continuation, how does a fuse work? The primary job of a fuse is to break the circuit. If a current is higher than desired is drawn by the circuit. The simplest kind of the fuse consists of a resistive element, selected carefully for its melting point. When a current passes through this element, a small voltage drop is small enough so the circuit downstream won't be affected. It is created across the element and some power is dissipated as heat. The temperature of the element thus increases. On the symbol of a fuse, the standard IEEE or ANSI symbols for the fuse is as follows. However, the IEC fuse is slightly different.
Types of fuses. Fuses can be divided into two major categories, AC fuses and DC fuses. The below block diagram illustrates the different types of the fuse under each category that we will be briefly discuss later on. There are 5 subcategories of DC fuse, which are cartridge fuse, automotive fuse, resettable fuse, semiconductor fuse, and over-voltage suppression.
Cartridge fuses. This is the most common type of fuse. The fuse element is encased in a glass envelope that is terminated by metal caps. Since the glass envelope is clear, it is easy to visualize determine if the fuse is blown. There are many variants of this design. A larger element that can handle overcurrent for a relatively short period of time and are unaffected by spikes in the appliance are called slow blow fuses, while fuses that react instantly to current spikes are called fast blow fuses. Next one is the automotive fuses. These fuses are specially designed for automotive systems that run up to 32 volts and occasionally 42 volts. Some of these types are also used in other high-power circuits. The resettable fuses or polyfuse, like their name suggests, these fuses are self-resetting. They contain carbon black particles embedded in organic polymers. Normally, the carbon black makes the mixture conductive. When a large current flows, the heat is generated which expands the organic polymer. The carbon black particles are forced apart, and conductivity decreases to the point where no current flows. Take note that conductivity is restored as temperature decreases. Thus, the fuse does not have to be physically replaced. This kind of fuse is called a PTC, meaning positive temperature coefficient, since resistance increases with temperature. PTC fuse is ubiquitous in computer power supplies and phone chargers. They are particularly handy here since replacement is difficult. For the same reason, they are used in aerospace devices. The semiconductor fuses. The power dissipated by a semiconductor increases exponentially with current flow, and hence semiconductors are used for ultra-fast fuses. These fuses are usually used to protect semiconductor switching devices that are sensitive to even small current spikes. And lastly is the overvoltage suppression. Sometimes, voltage spikes can be harmful to circuits too, and often an overvoltage protection device is used with a fuse to protect against both voltage and current spikes. NTCs, or the negative temperature coefficient, are placed in parallel with the supply. When the supply voltage spikes, NTC fuses decrease resistance due to higher current flow and absorb spikes.
AC fuses. There are two subcategories of AC fuses, which are high voltage fuses and low voltage fuses. Let's talk about high voltage fuses. High voltage fuses are used in high voltage AC transmission lines where voltages can exceed several hundred of kilovolts. We have two types: HRC, or high rupture current fuses, and expulsion fuses. HRC fuses. These fuses are cartridge-type fuses consisting of a transparent envelope made of steatite, or also called magnesium silicate. The fuse is filled with quartz powder, which in case of liquid-filled HRC fuses on non-conducting liquid like mineral oil, that acts as an arc extinguishing agent. These fuses are used for very high fault currents. Expulsion fuses. These fuses are filled with chemicals like boric acid that produce gases on heating. These gases extinguish the arc and are expelled from the ends of fuse. The fuse element is made of copper, tin, or silver. The other subcategory of AC fuse is the low voltage fuses. These fuses are used in relatively low voltage distribution networks. We have 5 types: cartridge fuses, dropout fuses, rewirable fuses, striker fuses, and switch fuse. The cartridge fuses. They are very similar to cartridge of DC fuses. They can be plugged in, which is a blade type, or screwed into a fixture, which is a bolt type. Dropout fuses. They contain a spring-loaded lever arm that retracts when a fault occurs and must be rewired and put back in a place to resume normal operation. They are also a type of expulsion fuse, which was tackled a while ago. Rewirable fuses. They are simply reusable fuse in homes and offices. They consist of a carrier and a socket. When the fuse is blown, the carrier is taken out, rewired, and put back into the socket to resume normal operation. They are somewhat less reliable than HRC fuses. Striker fuse. This fuse is provided with a spring-loaded striker that can act as a visual indicator that the fuse has blown and also activate other switchgear. And lastly, switch fuse, a handle that manually operated to connect or disconnect high current fuses.
Now that we know about fuses, let us talk about circuit breakers. What are circuit breakers? It is a mechanical switching device that can make, carry, or break a circuit either manually or automatically, under normal and abnormal circuit conditions. A circuit breaker can make, carry, or break currents is called normal conditions, while a circuit breaker can make or carry for a specific time and break the currents is called abnormal conditions. Now, what are the classifications of circuit breakers? There are several ways of classifying different circuit breakers. Some of the common criteria are intended voltage applications with low voltage circuit breakers used at voltages up to 1000 voltages. High voltage circuit breakers used at voltages greater than 1000 voltages. For the location of installation, it is indoor and outdoor. For the design characteristics, it is based on the physical structural design and it is usually done in two ways: the dead tank type circuit breakers and live tank type circuit breakers. Arc extinction is the method and medium used for current interruption. Types of circuit breakers. Just like the fuses, circuit breakers has two major: AC circuit breaker and DC circuit breaker. This diagram illustrates the different types of circuit breaker under each category that we will briefly discuss later on.
Number 1 is air magnetic circuit breakers, also known as arc shoot circuit breaker. The type of circuit breakers that work at the high atmospheric pressure area. So there are two types of air circuit breakers. Are the plain air circuit breaker, which is also known as cross plus circuit breaker. In this, the circuit breaker is fitted with a chamber that surrounds the contacts. The arc is made to drive. In achieving the cooling of the air circuit breaker, an arc shoot will help. Another one is an air blast circuit breaker. Air blast circuit breaker are used for system voltage of 245 kV, 420 kV, and also even more. So now we moved on the eggshell blast breaker under the air blast circuit breaker. Eggshell blast breaker is the moving contact of the eggshell blast breaker will be in contact. The nozzle orifice is fixed to the contact of a breaker at a normally closed condition. A fault occurs when high pressure is introduced into the chamber. Voltage is sufficient to sustain high pressure air when flowed through the nozzle orifice. SF6 circuit breaker. SF6 circuit breakers is the current carrying contacts operate in sulfur hexafluoride gas, an excellent insulating property and high electronegativity, the high affinity of absorbing free electrons. The negative ion is formed when a free electron collides with the SF6 gas molecule. It is absorbed by the gas molecule. The negative ions which are formed will be much heavier than a free electron. For heavier and less mobile charge particles in SF6 gas, it acquires very high dielectric strength. It is 100 times more effective in arc quenching media than an air circuit breaker. Vacuum circuit breaker. Vacuum circuit breaker is a circuit in which a vacuum is used to extinct the arc. It has a dielectric recovery character, excellent interruption, and can interrupt the high frequency current which result from the arc instability superimposed on the line frequency current. The principle of operation of vacuum circuit breaker will have two contacts called electrolytes. It will remain closed under normal operating conditions.
Oil circuit breaker. In oil circuit breakers, an insulating oil is used as the arc extinguishing medium. As the contacts are opened in oil, when the arc strikes, the surrounding oil is evaporated as hydrogen gas. The hydrogen gas bubble will surround the arc region. Hydrogen gas, due to its thermal conductivity, cools the arc and also deionizes the medium. The different types of circuit breakers in oil type are bulk oil circuit breaker and minimum oil circuit breaker. Bulk oil circuit breaker, or the BOCB. Oil is used to arc the quenching media and also for insulating media in between earth parts of circuit breaker and current carrying contacts. For the working principle, when the current carrying contacts in the oil are separated, then an arc is generated between the separated contacts. The arc which is established will produce a rapidly growing gas bubble around the arc. The moving contacts will move away from the fixed contact of the arc, and this results in the resistance of the arc get increased. An increased resistance will cause lowering the temperature, hence the reduced formation of gases around the arc. Minimum oil circuit breaker. It utilizes oil as the interrupting media. The minimum oil circuit breaker will place the interrupting unit in an insulating chamber at the live potential. But insulating material is available in the interrupting chamber. It requires less amount of oil, so it is called a minimum oil circuit breaker.
Now, let's talk about GFCI or the ground fault circuit interrupters. First, what is a GFCI outlet? A GFCI is a protective device specially designed to break the circuit every time there is an imbalance between incoming and outgoing current. It protects electrical wirings receptacles from overheating and possible fire, greatly minimizing the risk of shock injuries and fatal burns. It also detects ground fault and disrupts the flow of current, but should not be used to replace a fuse as it does not offer protection against short circuits and overloading.
How ground-fault circuit interrupters works? Simply put, usually a normal electrical outlet has two vertical slots and a round hole just below them. The larger left slot corresponds to neutral and right slot is called hot. The third round hole is the ground. Normally, electricity flows from hot to neutral in an outlet. The GFCI or ground fault circuit interrupters works by measuring the current leaving the hot sides of the power source and comparing it to the current returning to the neutral side. If they are not equal, this means that some of the current is flowing along an unintended path, possibly through water or through a person. The GFCI or ground fault circuit interrupters detects imbalance in the current flowing from hot to neutral. Imbalance in the current flowing from hot to neutral and quickly cuts off electricity, thus reducing the risk of electrical shock. The sensor inside a GFCI detects the difference between the current flowing to the appliance and the current flowing from the appliance. If the electricity flowing into the circuit differs by as small as 4 or 5 milliamps from the returning, a GFCI quickly turns off all the power by tripping a relay within it within a few hundredths of a second, much before the user hardly feels the shock. When the problem is corrected, GFCIs can later be reset to restore power to the affected circuit. If the problem still exists and GFCI continues to sense the difference in the amount of electricity flowing into the circuit to the flowing out, it will not reset.
Now, where is a GFCI outlet needed? A GFCI outlet are important, especially when the electrical outlets are positioned close to the water. Installing a GFCI outlet in your kitchen, bathrooms, laundry rooms, full house, etc. is a good idea. Apart from being an essential preventive measure, the law also requires you to have a GFCI outlets installed throughout your home. According to the National Electric Code or the NEC, all homes must be equipped with a GFCI protection. A GFCI outlet should also be installed on temporary wiring system during construction, renovation, or maintenance of structures that are using power temporarily.